Okay, today we're going to explore 13.3 dilations and measurement. If you read on here, it says to use the centimeter ruler to measure and record the length of the sides. Well, we've made it easy by giving you the centimeter ruler on the back. So if you turn your paper over, you will see that there's a centimeter ruler on the right-hand side and on the bottom. So what I want you to do is I want you to fold the paper so that the centimeter ruler is on the edge, and same thing for the bottom. Fold it as close to the bottom as you can get so that you can actually lay it on the figure to measure. So when you read the directions, it says that the blue rectangle is a dilation of the original. Well, obviously we have no color on our paper, so the way that we can determine the new figure, again, is to always look for prime notation. So the blue is actually the large rectangle. So what I want you to do now is I want you to use the centimeter ruler, and you can do this by folding the paper so that you can measure. You can fold from the bottom and you can measure. Make sure you set your 0. You're going to have to kind of bend the paper a little bit and make sure 0 starts on the edge. So go ahead and measure both AB and then AB prime. So do all of the measurements and then complete the ratios using the measurements that you got. Try it. Hopefully when you began measuring, you realized that you only had to do one side of both the vertical and the horizontal piece on each of the rectangles because it is a rectangle, opposite sides are congruent. So now take your measurements and write your ratios of A prime B prime to AB. Again, new to original. So after setting up all of my ratios, 4 to 2 equals 2, 3 to 1.5 equals 2, 4 to 2 equals 2, and 3 to 1.5 equals 2. So let's go through and take what we have on Part A to finish the questions on our own. Okay, so the first question says, what is true about the ratios that you calculated? Well, since they all equal 2, we know that the ratios are the same, or they all equal 2. So what is the scale factor? What scale factor was used to dilate the green rectangle to the blue, which is actually the original to the new, because we already determined up here that the blue rectangle is a dilation of the original and the blue is the large one. So we know that again the scale factor was 2 because they all equal 2. How are the side lengths of the blue or new rectangle related to the side lengths of the original? Well, the new side lengths are twice as long as the original. Now let's go through and answer some questions about perimeter related to these. So again, let's go through and change something. So our green is our original and our blue is our new. So anytime you see green, it's your original, blue, it's your new. Remember that when you find perimeter, you must add all of your sides. Calculate those perimeters. So when I went to the original rectangle, I added 2 plus 2 plus 1.5 plus 1.5, which equals 7 centimeters. When I did the new rectangle, it was 4 plus 4 plus 3 plus 3. And there are other ways to get that perimeter, so you can do it whichever method you choose. But now that gave me 14 centimeters. So the next question asked me, how is the perimeter of the new rectangle related to the perimeter of the original rectangle? Well, if I were to take 14 and divide it by 2, 14 divided by 7, I would get 2. So again, the perimeter of the new rectangle is twice the perimeter of the original rectangle. Now let's answer some questions about area. Let's remind ourselves that when we find area, we multiply the side lengths. So try that on your own. Okay, so when we look at the area of the original, it's 2 times 1.5, which is 3 square centimeters, while the area of the new rectangle is 4 times 3, which is 12 square centimeters. So now they're asking us to see what relationship the new rectangle has with the original rectangle. Okay, so how is the area of the new related to the area of the original? Well, we can do two different methods. We can do our new to original, so 12 to 3, well 12 divided by 3 is 4, or we can use the formula original times scale factor equals dilation. Well, our original was 3, our new is the dilation, so we do 3x equals 12, divide by 3, and x equals 4. So again, either way we get a scale factor of 4, which tells us that the area of the new rectangle is 4 times as large as the original rectangle. So we have a special little power circle to help us remember things. When you are multiplying the original, if you are doing perimeter, so you take your original perimeter or your original area or your original volume, multiplying by the scale factor to a specific power. The number that goes in the power circle will be a 1 if you're doing perimeter, a 2 if you're doing area, and a 3 if you're doing volume, because that will give you the relationship between the original perimeter area volume and the new perimeter area or volume. So let's practice. Draw the dilation of each figure. Then find the perimeter and area of each figure and its dilation. So we have a scale factor of 3. So you're going to take your original, which is 1, 2, 3. So if I have a scale factor of 3 and an original length of 3, 3 times 3 makes my dilation 9. So I'm now going to draw in a dilated figure that is a 9 by 9 square. Okay, so my original figure is a 3 by 3, so 3 times 4 gives me my perimeter, so it's 12 units, where my dilation is 9 times 4, which gives me 36 units. Now the area of my original figure is 3 times 3, which is 9 square units. Now let's think about that power circle. So we're dealing with area. Our original area was 9. The scale factor is 3. Because we're dealing with area, we're going to multiply it times 3 squared. So you can put into your calculator 9 times 3 squared, which will give you 81 square units. So now let's look at a scale factor of 1/4, which means we know our figure will be getting smaller. So my original 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and 8. So my original is 1/4 my scale factor times 4. Well, 1/4 of 4 is 1, and 1/4 times 8, and 1/4 of 8 is 2. So my new figure is simply a 1 by 2. 2, 1. Now find the perimeter of both the figure, the dilation, the area of the figure, and the area of the dilation on your own. Okay, so this time I decided to add 8 plus 4 and double that for my perimeter because I know there's 2 of each side, 24 units. 1 plus 2 times 2, 6 units. Area of my original figure was 8 times 4, which is 32 square units. So again, I'm going to use the power circle method, and I'm going to say my original times my scale factor, which is 1/4. Again, because it's area, it's 1/4 squared. Well, 1/4 squared means 1/4 times 1/4, which is actually 1/16. So I have 32 times 1/16, which is 32 divided by 16. So I get 2 square units. So let's look at this last example. A group of friends is roping off a soccer field in a backyard. A full-size soccer field is a rectangle with a length of 100 yards and a width of 60 yards. So I drew that out to the side. To fit the field in the backyard, the group needs to reduce the size of the field so its perimeter is 128 yards. So the first thing we're going to do is figure out what is the perimeter of a full-size soccer field. So do that now. Okay, so my perimeter of my full-size soccer field is 320 yards. So now I've got to calculate my scale factor, and to do that I did my original times scale factor equals dilation. So my original was 320 because that was the original size, times my scale factor, which is what I'm trying to find out, and I know that they want a perimeter of 128 yards, so I'm using what they gave me in the problem. So I'm solving for x by dividing by 320. So I put in my calculator 128 divided by 320, and it gave me decimal point 4. So I can use decimal point 4, or if I prefer, I can use the fraction equivalent of 2/5. So now let's use the power circle method and find out what the area of the soccer field in the backyard would be. You try it. Okay, so the original area of the soccer field, as I'd already calculated up here, was 6,000 square yards. So if I take 6,000, the original area, times the scale factor of 0.4 squared, put that into my calculator. So I put in 6,000 times 0.4 squared. It gave me 960 square yards. Okay, as you begin working on your assignment, please refer to these notes, refer to the examples. If you need to watch the video again, please do so. Good luck.